Okay, I think I have started recording. Is there a way to tell?
Yep,
Oh,
ready
yeah,
to go.
yeah. All right. I will actually first, yeah, I just pulled up the website that Derek was saying. So, yeah, I don't have actually any slides. I'm just going to go through this one and then I just have some examples and we'll just run the R code directly. So for those who may not know, I think, so this reticulate package is a way to call Python functions and run Python from within R. And I think this package actually was written by JJ Aller, who is the founder of RStudio. And I think it really is kind of a game changer in the sense that uh, I think his intent was that he first wrote this package and now this kind of forms like underlying basis for other packages like TensorFlow that call Python. But then this is a more general purpose package that you could just use to call Python. And of course, obviously if JJLR has developed the package, I mean, it's pretty robust and well thought out. So it's pretty nice package. Now different people would have different use cases of using this. For me, I think I have to say that for typically if I need to use Python, I kind of try to be in Python. If I need to use R, I try to be in R. But I can kind of see places where, for example, if something is in Python, but I still want like a web app, I would kind of use reticulate within Shiny to call like the Python code. So that's a use case I can see. But then I can also kind of see that there are certain things where both Python and R have their own packages. So maybe you don't need to exactly call Python from R. But then in cases where somebody has written a Python code, I think that's a good use case. You don't need to rewrite that code in R. You can just call that code from within R. Now, in terms of setup for using this reticulate package, you do need to have Python and whatever packages you need installed in your system. And today we probably won't be covering it. So as long as you have a Python install along with its associated packages, it should work. Um, and and then here they have some examples. So they have these different examples of R Markdown, where so typically probably people are familiar with the typical R code chunk in R
Sorry, do you
Markdown.
guys see the screen?
Oh, good.
Yeah, you might need to share the screen.
Thank you. I forgot to share the screen. All right.
There we go.
All right.
Perfect. How do I... Yeah, so I was just in the package website, the reticulate package website, and I was just going through some of the intro stuff where I think they have an example of calling um, this from Markdown, and maybe I'll just create a new file. So I can just say R Markdown and so actually on second thoughts I'll come back to this because I probably need to have because there's a couple of steps we need to make sure that it's using the right version of Python. But once it's there, you can kind of see this R code chunk where they're running like a ggplot command to make a plot. And now with this reticulate package, if you import reticulate, you can also have a Python code chunk where all of this is actually straight Python code where they're reading a pandas data frame and then doing something with it. The other way to call is just directly within R code, you call Python modules, and we'll take a look at some of the examples right now. And then you could also, if you had a Python script, let's say you can just source that Python script within R by saying, if you say source Python flights.py, and then in this Python code, you had like the read flights function. Now you are able to call that read flights function from within R. And then you could do like a plot with any R plotting thing. And they also even have a way to kind of start a Python REPL in R. Let me try that actually. Is the font big enough? Are you able to see the font in the screen?
Yeah, I can see it pretty good.
Okay. Yeah. Huh. I'm not sure why that is not working. Well, we'll come back to it. So things that don't work, we'll come back at the end. So yeah, I'm going to jump into just actual examples, but I would say the way I have used Reticulate, and which is probably more of what I'll cover today, is mainly this way of directly calling the Python modules, because kind of if you are just using like a Python function within R code, it's kind of more easier to like use it in other R codes and stuff. Whereas if I have like combination of Python and R, it's just that I don't use notebooks as much. Probably I should, but right now I'm not using as much, so I don't do this kind of an approach too much. And same way, if instead of sourcing Python scripts, another way is actually you can import the script also as a module. So both ways work. So pretty much what I'll be covering today is kind of this way of importing it as modules. So let me actually open. So we kind of already ran this command. So if you right now, kind of in my mission, if I do like let's see. So if I just say which Python, okay, in this case, it's actually already looking at this version of Python, but then here, if I do like a so PyDiscover config is a reticulate function to kind of see what are kind of the different Pythons available in the system. Because so if I don't do anything, it's going to go to the default Python that's installed with Mac, which is probably like 2.7. And we kind of need to tell it, and then it says that these are the other Python versions found. And then so to make it use the Python that you want, you can use this command use Python. So if I kind of run this one, and now I try to do the PyDiscover config again, you can see that now the Python it's using is this one. So now I'm using the right version of Python. Now in the Reticulate documentation, they also have this pyconfig command, and I'm not sure why it happens, and maybe it just happens for me. For example, if I do pyconfig also here, it will kind of list the similar kind of output. First, it will say that I'm just using this user bin Python, but somehow it sets the configuration. So when I run this command, the use Python command, it doesn't change the Python version. So what I found is if I use this PyDiscover config, it lets me change it. So I've been using PyDiscover config. Like I said, there's probably a reason to it, which I don't know, but this seems to work. And then, so in Python, typically you would kind of, just like in R, we have library packages. And of course, for folks very familiar with Python, please bear with me if some of this is very basic. So the equivalent of library, some package in Python is you would say import some package, or from some package, import some function, or things like that. So Reticulate kind of gives some, I think this, when you say import main, it just gives you access to the Python things that it runs in the background, the functions and so on. And then Python has some built-in functions. So this command kind of just imports that. And we'll kind of see some examples of where we use it. But now let's say that, So here first I'll take just an example of NumPy. NumPy is a very like a key scientific computing library that works with matrices in Python. So for example, so here I'm in a Jupyter notebook. So if I were to just import NumPy in Python, I would say, let's say import NumPy as NP. And then let's say I just want to kind of create a NumPy array. I would say, let's say 1, 2, 3, and just using some basic command. So x dot sum would kind of give 6, and then x dot cumulative sum actually gives like the cumulative sum of this array. So for example, if I was just in pure Python, this is what I'll do. And you'll see that actually I would not claim I'm an expert on reticulate, but then certain just basic syntax translations, if you do, you can write the R version of it. So for example, this import NumPy as NP, you would kind of just say NP equals import NumPy. So it will do kind of what we did there. And here, so here we explicitly defined a NumPy array, and here I'm defining a R vector, say 1, 2, 3, 4. But now, if I want to call this one, this x dot sum, all I would say is that in this case, I would kind of write it this way. So np dollar sum x. Actually, let me try this. Yeah, I think here I would need to call it this way because we explicitly call the NumPy. So if I say np dollar sum x, it kind of adds up this. And what it's doing under the hood is they have these different translation of R type to Python type. So when you have just a vector, and when you pass it into this function, it automatically converts it to a NumPy kind of a list or a NumPy array. And then here, same way, here instead of x dot cumulative sum, kind of if I do this, it basically did the cumulative sum. So it's actually running the NumPy Python function to calculate this. Of course, these are toy examples. I mean, you don't need Python to do this, but just as an illustration, that it's fairly simple if you know what the Python function is, that this would work. And then this is just another example where, let's say, NumPy has a function for calculating eigenvalues and eigenvectors. So if I go to this site here, so let's say I come across this function numpy.leanalg.eig, which is the function for calculating eigenvalues and eigenvectors. And I look up this example, it looks like, so they want to do like a from NumPy import linear alg as LA. So basically the R equivalent would just be, so I'm saying this LA is import numpy.leanalg. So that would be the equivalent of this. So if I run that, it kind of imports that. And then here the input to this is a matrix. So here they are defining the matrix as a NumPy array, but we are just defining it as a R matrix. So this is kind of our R matrix. And here you see that the command is la.eig and the matrix that you're passing to it, and it returns two things. One is the eigenvalues, which is a vector, and then the eigenvectors, which is a matrix. So just looking at this command, all we need to do is wherever you see a dot, put a dollar. So we can kind of say la dollar eig a instead of la dot eig a. Now here it has returned it as a tuple in Python. So here I'm just storing the result in this igress. So if I run this, it's now actually a list. So the first element of the list is this here, this 1 plus j, 1 minus j. Here in R, the complex number is printed as I instead of j. And then if we run this, this is kind of this matrix. So you can kind of see that really this package makes it kind of easy. If you see like some written example or command here, there's not too much different you need to do. I think my rule of thumb is where there's a dot, put a dollar, and then and then mostly you'll be good to go. And then there are a few other things that we may need to do, and we'll get to that.
Excuse me, should we hold our questions to the end, or?
Oh no, feel free to jump in. Yeah.
Okay, well, two quick questions. One, early on when you were talking about referencing different distributions of Python you had on your machine. Say you had a bunch of environments on your machine, kind of environments. Can you reference those particular environments?
Yes. So if you have environments, actually, you will use this command. So where instead of use Python, you will actually say use, if it's a virtual environment, you will say this.
Okay.
Or if it's a Conda environment, you will kind of say this, and then it will point to that.
Okay, that's the first question. I didn't see that when you scroll through. The second question is, I'm assuming that translation is probably only good, like only available in NumPy or Pandas, or are there a list of packages where you can, do that translation where if it's dot whatever method in Python, you use a dollar and that same name in R. Is that just for Pandas and NumPy, or is it pretty much, are there a lot more packages?
Good question. So that the dollar kind of thing would, I think it's more general. It's not just for NumPy and Pandas, but the key is when it does the translation of the argument from R to Python, the receiving Python function should recognize it. So if the receiving Python function is taking a list or a NumPy array, it can be in any package, and this would work. But if the Python function has its own custom type or something that it's taking, then it could get a little tricky. And I think I have one example of something like that, but there it probably might depend. But if it is taking like a regular, like a Python list or NumPy array or dictionary as the argument, it'll work.
Okay, all right, thanks.
So here this one I kind of took, so here I just have different examples from different, I just looked up, different Python packages for examples, just to show how I can just use reticulate very easily to kind of replicate a Python example that they have. I think this is something from the signal processing one, and I think here they had some piece of code. Yeah, they had a piece of code where they take this image and then blur it. And they are using these functions from SciPy. So, so if we wanted to kind of replicate this, for example, so we already have imported NumPy, so we already have that. Now we need to import this. So here they have done it in one line, and maybe there's a way to do it in reticulate. But what I did is, so we are importing the signal and this MISC from SciPy. So I just do it in two commands. So this as import scipy.misc as one command, and then signal as import scipy.signal, and then matplotlib plot as this one. Now this one I'll touch upon. There's a little bit of an issue with the matplotlib in the console, but then if I want to run this thing, so here they have image as misc.ascent. So I just said, I think image is a function in R, so I called it im1 as, so instead of misc.ascent, I'm saying misc$ascent. And then W says signal.gaussian this. So where the dot was, I just have like a dollar. And then this is the one that does some kind of filtering. I don't know how exactly it does it in the background, but all I did was copied this, change the dot to a dollar, and got this. Now they have the matplotlib commands here to show the plot, and it actually shows it, but somehow it hangs my R session. Well, let me do it. I'll just restart the R session. And when I looked up some of the R Studio community forums, they said this matplotlib plot works better with Markdown. So I might be missing something here, but here what I did is I just took all of these commands here, and like I said, all the dots I replaced with dollars. So it does make the plot. So let me actually run it. So it kind of made this plot, and this is actually a matplotlib plot. You can actually like zoom and do things like that. And then if I go here and plot this IM1 new was the filtered image. And so let's see. Like I said, here is where it something happens with the console stuff. It kind of hangs, and I'm not sure. Yeah, so this is that blurred image. So you can kind of see that it kind of got this. So I didn't have to do much. Just copied pasted this code. In most places, just instead of the dots, I made the dollars, and it seemed to work, which was nice. Like I said, now something is going to happen. Okay, I'll try to force quit and restart. So that's the part I'm not sure. Sometimes, somehow, if I use the matplotlib command in the console, it does make the plot, but then it kind of it doesn't like it somehow. And like I said, people said, at least in the forums, that it works better with R Markdown. So anyway, we'll restart our session. Okay, and I will re-import these modules. So we already covered SciPy example. I think the next example I had was SymPy. So SymPy is a pretty interesting package. So what it does is it's like a symbolic package in Python, where it will do like differentiation, integration. It has a whole bunch of things. So for example, here they are showing an example that if you can define these symbols, and then if you say diff cos x of x, it's basically taking a derivative of cos x, and so it will kind of say it's minus sine x. Or if you're taking a derivative of exponential of x squares with respect to x, it kind of automatically puts what that derivative is. So it's kind of doing like a symbolic differentiation. And I think here they have a bunch of examples. They have some example of integration where they say, if you say integrate cos x with respect to x, it's sine x. So this is an interesting one. So if we want to kind of try and see, can we run this from R using reticulate? So that's the example I have here. Now in Python, many times they'll say in some codes, you'll see this. I think it tries to basically import all the functions into the main kind of thing. Now, some people say that's probably not a good idea because it may cause collisions. But anyway, I don't know exactly the reticulate equivalent of this. So what I'm doing here is I'm importing SymPy as SMP. So I would always preface any function call with this SMP. So let's import SymPy. And here it's actually, if you say define symbols XYZ, it's kind of putting it in a tuple. And so in reticulate, what it will do is it will automatically convert this to a list. So for example, and then here it says symbols, but that's because they have imported it as star. If you didn't import it as star, for example, if we said import SymPy as SMP, you will need to say SMP dot symbols here. So here I'm saying SMP dollar symbols. And so it kind of has created 3 symbols here, X, Y, Z. So I'm just saying X is the first symbol in the list. Now, I'll come back to this actually. So here they have this command for differentiate cos x with respect to x. So it's really smp.diff. So all I do is I say smp$diff. And then again, this cos function is a function from within SymPy. So I preface it also as smp$cos x. So if I run that command, so it kind of found the answer as minus sin x. Now here is where it gets a little tricky. Now, for example, if I, so here they're differentiating e power x square with respect to x. And if I do the same thing, so I say smp$ differentiate smp$x, and if I run this, now it runs into a problem because right now this exponentiation operator, it still is based on R. So it's looking for R objects here. So it doesn't recognize that this is kind of should take the Python object. And actually in one of the reticulate issues, I think JJ Aller had commented, somebody had commented that, okay, do they need to define specific operator functions? Now, I don't know if that is the cleanest way, but at least in that thread, JJ Aller kind of seemed to say that that's probably okay. And I think I took some code for that where I'm just kind of defining another function for that exponentiation operator based on if a Python object is passed. So if a Python object is passed with an exponentiation operator, I'm just saying that this is the command. So there's a package in Python called OP, and then like OP dot POE a comma b would take like a raised to the power b. And so if you kind of define this operator as this way, it basically kind of gives a way to calculate that. So for example, if I run this one and then run this one, oh, I guess I needed to run first this one. So if I run this one, then followed by this one, then this one. Yeah, so now when we ran this, it kind of gave this answer 2 times x exponential of x squared. So 2 times x exponential of x squared. So that was actually a kind of a learning for me because sometimes that makes it even more generalizable that as long as sometimes all these powers and mathematical operators, you can overload it this way, that then it becomes even more easier to use with some of the other Python functions, like in this case. I think this was the example where they integrate cos x, so you get like a sin x, and then let's see what this was. I think here they actually have things like they can do like series expansions. So I don't know about you, back long time back, probably in school or college, they would have talked about all these series expansions for log, sine, cos, and whatever. So here I'm saying e power sine x. So you can just define it symbolically as smp$ exponential smp$ sine x. So if I kind of look at the expression, so it's this exponential of sine x. Now if I want to show like a power series of this with 4 terms, you can just say this dollar series. Actually, let me do this. So the arguments to that are I think 0 to 4. And now you'll kind of see an error here. So that is one thing. When R passes a number, it is taken as float within Python. And then within Python, this function wants an integer. So that's why it's giving this error. So if the Python function needs integer as an argument, you have to explicitly pass it like the long integer in R. So when you kind of do this, now it kind of got this as the series expansion for that. So that's just a few examples from these packages. And then there is a way to explicitly convert R to the Python object before passing it. Like if it's not doing what you want, sometimes that may work. And so here I'm just showing as example what happens kind of. So this is one way to check really when you pass a particular object from R, what is it getting converted to Python. So for example, if we just say R to Py1, so it converts this, and then I'm just going to say, so in Python, so in R, if you say, let me see, so class is the thing to say what type it is. In Python, the equivalent of class is type. So for example, if I just say x equals 1, and then I would say type of x, so it's int. So here I want to, right now this is converted to a Python object, and I wanted to check the Python type that it is converted to. So I want to use the type function, but then the type function, that's where that built-in module that we imported comes in handy. So we say, and then the other thing is, once you import a package, when you say $, it'll actually list the different functions, just like with R, it will do it. So that's also a nice feature. So I can say type R to Py1. So if I do this, so right now it's running it within Python, and it's taking a Python object. It's saying that it's interpreting it as a float. But then if we do this one, and let's try type type R2Py1L. So if I do this, so it's taking it as integer within Python. So you can kind of see that when you pass it this way, it's doing it as integer. Sorry if you're hearing some background noise. And so
New normal.
So let's say an R vector here. So for example, when you do R to Py of the vector, it has converted it to a Python list actually here. And then a list, like a R list here, I'm just taking, that is also converted to a Python list. Now this is something I'm not sure. In the reticulate, the documentation, it says that a list will be converted to a tuple, but yeah, that doesn't seem to be happening. Not sure why. So it still gets converted to a list. But if you have a named list in R, that will get converted to a Python dictionary. So for example, if we take this, which is a named list, so you can kind of see here that now this is just converted to a Python dictionary. So you can kind of see the back and forth, how the R object is converted to a Python object. And similarly, I think there's ways, let's say something that comes from a Python function, if it is not quite converted to an R object, you can do like a Py to R explicit call. So I think we covered some basic examples where, I mean, like I said, it was fairly easy to copy like a Python function, make some tweaks to it, and run it. There's more things in terms of, I think you can actually also do like iterations and stuff. I haven't quite explored it in that much detail. So for example, they have here some examples where if you have an iteration in R, kind of somehow how that could go to Python. So like I said, I've covered some portions. There's probably more here which I didn't get into. And then they also have certain ways of specifically getting to attributes of Python objects and things like that. So I don't like probably today we may not be covering all that, partly because I haven't used those that much. Now maybe we can go to the next example. So again, all of the examples are in similar vein. I just took a package, try to use an example from that. So let's open this one. So for example, now R also has several things for machine learning and stuff. So you may not need to use Python, but let's just say there's some particular Python function. Yeah, so this is just an example I'm taking that. Let's say you come across this example from scikit-learn, which seems to use some Gaussian process classification, and let's say you want to call the code from R. So if you look at this example, what they are doing is, I think they have generated just a simulated data where they randomly generated data in this between I think random normal between with yeah, I think this random normal. But what they did is they kind of assigned a class of one particular class for these two quadrants and another particular class for these two quadrants. And the goal is to use this data to run this Gaussian process classification to see if it recovers these classes. So when you run this algorithm, if you pick a point here, it seems like with these input parameters, it kind of recovers the class, whereas with this input parameters, it more sharply recovers the class. Like I said, I don't know the exact details of what goes on behind it, but the goal here was, can I create an R code for this? And if you look at this code that they have in the example, essentially what they're doing is kind of, they are creating a grid of 50 by 50 between -3 and 3, setting like a random seed, and then they are creating like random normal 200 points with kind of like a x1 and a x2. So that's what they're doing. So all of this is just generating this data and putting a label to it. So that's what they're doing. And then here they loop through both options for the parameter. So that's why they have this for loop that is going through these kernels. And the key function that does the classification is these two. So they define a process classifier dot fit x comma y, which does the fit. And then once it does the fit, they are doing like a prediction based on this full grid. So basically they're doing a fit based on this data, and then with the fit, they're doing a prediction for this 50 by 50 grid point here, which is what is then plotted as a color here. So for our purposes, you know, the main Python function we need here, which is part of scikit-learn, are these two. All of these other things, we could just do it in R. And even the plot here, we could do it in R. So that was kind of the goal with this example, to see that, okay, if there was a use case where there's a particular function we are interested in using, but then the rest of the code could be in R, what can we do? So if we go to the R file, so we already imported reticulate. So here I'm just importing some of the R packages we'll need, and we already kind of imported all of this. So now this part is the equivalent of these two. So kind of this sklearn.gaussian process classifier. Yeah, so I'm saying import, I'm saying import this one as this skg, and then import this one as this skgk. I mean, I just put in some abbreviation. But then here I'm just using R to get the data. I'm kind of actually, let me import this one, this one. So here I'm just setting the seed here. And then this is where I'm just simulating like a normal random variable. And then this is what defines like that quadrant function. And I'm just converting it to a data frame which has a y. And if I do like a ggplot of this data, we can kind of see that it kind of created the data set, like these two quadrants are one particular class, these two quadrants are another particular class. So now for this data, we want to run that classifier. Here I didn't do it in a loop, I just did it one by one. So you can kind of see that for this command here, this command here, so all I do is I basically just take that command directly. Only thing is I preface it with that skg, because here directly from this, they had imported the function. Whereas in R, I just imported this, so I needed to preface that. So this one is this skg. So I'm saying skg.Gaussian process classifier. And then kernel equals. So here they say kernel equals kernel, which is like in the loop, the first one would be this one. So I could directly put this here, except that again, this RBF is a function from this. So I just needed to preface the RBF with this. And then instead of the dot fit x comma y, I do like the dollar fit x comma y. So pretty much I was able to take that code. So now here we run into a problem, the same problem, because when it looks at this multiplication thing, it doesn't know what to do because it's seeing two Python objects. So actually what I have here is I had created a file called operators.r, where just for the basic operators, what we did previously, kind of just overloaded them, that if it sees a Python object, it uses that Python thing. So let me do like a, okay, once we do this, now if I run this command, so it works now because now it knows what to do with this multiplication operator. So now we need to predict this. So this is that the full grid from -3 to 3 for x1 and x2. We are creating it in R. But then now we are using this Python function, the clf.predict probability. So I'm just saying clf.predict this and then passing the R matrix to it. And it actually outputs two classifications because it's like a probability. So we just need the second one here. So when I run it, that gives it. And so I'm just creating a data frame with that grid of x values and the predicted y values. So now all of it is in R, and then if we just do like a typical ggplot one, we kind of get this. So just kind of similar to this. Now they probably have this line. I don't know how exactly they drew, but the contour is kind of coming close to that. And now if you use the other kernel, which was, this one dot stuff. So here is running the same command, but with that other kernel. So I just copied the same thing here again, just that I have this preface. So if I run this, and then rest of it is kind of same. And then now if I plot it, so it kind of gives more the equivalent of this. So again, this is an example where, okay, we kind of saw that, maybe we want access to these two functions, this one and this one. So you could still do all the rest in R, and then at the right place, you could just call these two functions and do even your plotting in R. So that made it convenient in this particular case. The next example I have, maybe I won't go through, maybe I'll go through it a little fast. Let's see. Yeah, okay. So I don't know, maybe how many folks are familiar. So if you're interested in like Python, deep learning kind of stuff, I really like kind of this one. So this is by like Jeremy Howard and oh, now my head, I'm missing the other person's name. I think she also has a blog here. Rachel Thomas. Yes, Jeremy and Rachel Thomas. So they have some nice courses for like deep learning, and their approach is pretty nice. They actually start like top down and first kind of pretty quickly get you to do something that is working and then kind of go more into the details. Pretty nice approach, and they give a lot of, so I think they have like lesson videos here, and then they also have like Jupyter notebooks. And as part of this course, they have actually developed a software called Fast AI, which is actually a wrapper around PyTorch, but makes a lot of the typical deep learning tasks much easier to do. So somebody interested in this type of stuff, I mean, this is a good resource. So what I did here was I went to that Fast AI software documentation site. Let's go there. And here they have these different tutorials, but I kind of wanted to see, they have this collaborative filtering tutorial. So collaborative filtering is when like multiple users rate multiple, like in this particular example, I think there's an IMDb or movie lens data set with I think about 100,000 points. I think they have kind of taken a subset of the data where different users have rated different movies, and so they are actually building a model for predicting the rating of movies. And so this is kind of a tutorial that just walks through it. And like I said, for folks interested more in the actual model build process and stuff, I think in that course there's a whole video lecture on that. So we won't get into the model details and stuff, but the video is a good resource. But what I wanted to show was that, or what I wanted to try was, all of this is like a Python code. So can I use Reticulate to run most of this? And the nice thing with Reticulate is, for the most part, I was able to do it. I think there were a couple of places I needed to do something, and we'll maybe take a look. So, so for example, here, kind of, yeah, we already imported all of this, but then I'm just importing this tabular.all.collab. And then here we need pandas also. So we kind of imported all of this. So for example, I didn't know exactly what it is doing, untarring and getting it to what and stuff, but I just blindly followed the thing. I took this, and wherever there was a dot, I put a $, and it kind of found the path. And then in this case, they already have a pandas command for reading in the data. So here's where, for example, I mean, so I wanted to directly use this command. So you can kind of see that here they directly say path, comma, u.data. And I wasn't sure how that would work. So I explicitly created the pasting of path with udata so that the data path had the full file name, so that I could pass that as the first argument instead of this. This part I kept the same. So now they have header as none. So in R, we'll need to pass it as header as null. And then here they have use columns like a tuple of 0, 1, 2. And so here we'll need to pass it as a R vector of 0, 1, 2 with that L command. And then same way here, it's a Python list for the names of the columns. So we pass it a R vector. So here what it gets is a Python data frame, but here what it will do is it'll get a Python data frame and convert it to a R data frame. So if I do head ratings, you kind of get this one. So we can do similar for the other two. I think they have like a data set for movie titles. So if I do the same thing there, it just gives the title of the kind of each movie ID, what title is it corresponds to, and then so here I'm just, so here they are doing it within pandas, but I'm just doing it within dplyr, doing the inner join to get the title along with the ratings. So I have user movie rating and then the name of the movie. And then here is where, for example, they start using their kind of, in that Fast AI has these different functions to do stuff. like I said, I don't know all the details. I may have to go back to the video and refresh myself. But kind of, I just copied this and changed the dot to dollar and then the 64 to 64L. So it kind of seemed to work. Now the one thing is their show batch, it seems to work only in Jupyter Notebook with HTML code. So that part didn't work. So it just gives me this object, but I don't know how to display it here. But anyway, now this is kind of the command to do like a learning. So the data is those user and movie ratings, and then this is the command that kind of does. They set up like the learning function, and then this is the thing that does like a fitting. So basically, I just copied this. Same thing that we talked about. 50 became 50L, and this tuple became like a R vector. And then here learn dot fit one cycle and then this one. So I said learn dollar fit one cycle, and so you can kind of see that when I do this, it's like this one. It's kind of working on it right now, so it'll kind of come here. Now the numbers may not be exact. I think this. So essentially in this model, I think they later go to like a deep learning model, but this particular model is just like a matrix factorization. So I think they use 50 factors. So, and then with like a bias per movie. So the idea is that the bias is a reflection, the estimated bias is like a surrogate for rating. So it's still working. Okay, so it finished. So here they kind of try to interpret the results from that. And very briefly, I think underlying it kind of splits the data into training and validation. And I think the metric here is just mean square error, I think. So essentially then what they try to see, and here all of it is just using like pandas and stuff. So the model that was fitted, so dot bias kind of gives the bias values estimated by the model. So here we say learn. So learn is the thing that has the model. So learn dollar model dollar bias, and then here we just do it for, let's say, the top 1,000 movies. So right now this is just R code to get the top 1,000 movies, and just listing like the top 10 in terms of the ratings, and then getting the movie bias for those movies. So now, for example, let's see what type the movie bias is, because if we kind of see, it's actually returning like a PyTorch type data structure. So we won't be directly able to use it in R. Now in Python, they could directly use it. And even if you type the R command class movie bias, it kind of says it's torch.tensor. And then here the Py to R conversion doesn't quite work, because in the base reticulate, it doesn't know how to convert a torch tensor to like a R object. And also if you just want to, let's say, look at it within the Python module, so there is a command in reticulate called pyrunstring that gives you access to the Python module that is running. And then this movie bias R that is right now in the R environment, sorry, this movie bias that is in the R environment, you can call it using r.movie bias. So for example, if we do this, it does give you like a so it gives this torch tensor. But what we want to do is we want to convert it to some R object that we can use within R. Luckily, PyTorch has a function that converts PyTorch data into like a NumPy array. So that's just called, in Python, you would do like that array dot NumPy. So if we just say movie bias 2 as movie bias dollar NumPy, Now, if I say class movie bias 2, so now it's become a R array. So now I could do like the usual dplyr stuff with it to kind of see, okay, so what are kind of the worst rated movies also seem to have like low values of bias, and then kind of the top rated movies kind of also have the best bias. So if you kind of plot the model bias versus the rating as just as a scatter plot, so the model bias seems to track the actual rating. And then I think they had some example with PCA and stuff. So I think this was actually a good example where when I started off on this, I was like, okay, let me give this a try. I wasn't sure how far along I could go, but I was quite impressed that I didn't have to do much and I could pretty much, replicate this whole notebook in R. So that's one example. Maybe the last one, I won't go through the example, but I'll just say this is what I wanted to show here is, I don't know, folks, if you're familiar with this person, Peter Norvig. He was actually a faculty in Berkeley. Now I think he's like a Google research director or something. I think, yeah, director of research at Google. But the nice thing is he has kind of interesting Jupyter notebooks where he'll just take something and work through it. And he's a fantastic teacher. If you just read through his IPython notebooks, I mean, there's a lot to learn. He explains it in very simple terms. You can see kind of he has a whole bunch of things. So for example, he has a notebook on how to do things with words. Now, there are right now many, a lot more sophisticated NLP packages and so on. But here, I think just using some basic ideas, he tries to illustrate how a spell checker, how could you construct a spell checker, or how could you kind of split sentences. So if I just said, I am here without any spaces, how could you make the computer split it into I space am space here? And he kind of walks through that. So I think in this example, all I wanted to show was that, let's say you didn't want to rewrite all of this in R. Maybe you can just have the functions he defined in a Python file. So for example, I kind of, from that IPython notebook, all the functions that he had, I just defined it in a Python file. Now, one option is to source this Python file, which is an option. But also the other option that works is you can just import it like we did the other thing. So if you say import, so this Python file is in the same directory called norwigwords.py. So you can just import it. So for example, if I kind of import it, I think he was reading this Gutenberg text. So a lot of this is I just took his Python code and then use the reticulate version. So let's say it has like these many characters, and then he had defined a function called tokens. So if I say wd.tokens, it kind of splits it into, whatever, this is a test. And then I think he had a function called sentence. So if I did this, it'll I need to run this and then this. So it kind of has a sentence. And then he had defined a word called like bag of words. Like I said, nowadays there are R packages and Python packages with built-in functions, but he had kind of defined his own function for this. So if I kind of run through that, it gives like the common words with the count. But the thing is here, I'm pretty much using the functions he defined in Python with this. Now the one part where I ran into a problem and I had to do that, and so that's why I think maybe I was trying to push reticulate too far. So in his code, eventually he gets down here where let's see. Yeah, he defines like an algorithm for segmenting sentences. So if you say segment this, Now there is two ways you can split this, but okay, it splits it as like choose pain or speed of art is like speed of art. So the function he has defined here is like a recursive function, and he's using some caching. So I couldn't get this to work because this relies on another object p word, which I think when you run it within Python, just like R, it kind of looks up in the environment if it is not if it doesn't find it in the function. But when you call this from reticulate, it doesn't know where to look for it. So that was a problem. So I tried modifying this function to explicitly pass it as an argument, and I probably made it slower. So it didn't work perfectly, but like I'll show you the change I had made in the function. So I kind of explicitly passed these words, and I was trying to calculate these p words again and again. So I kind of got with that one, I got it to work. But what happened was it kind of made it slower. So it kind of did this, kind of did this. Now this one takes a longer time, whereas in this code it will kind of run very fast. So yeah, I mean that's kind of a limit, but like I said, with these examples, at least for me, it seemed like this is a pretty powerful package. Lets you get pretty far with using, the Python code that others have built in your own R code. So let's see. I think let's see if we can get back into the. Hello.
Is there if you? I'm wondering if there was a hidden window somewhere underneath all of these other windows.
Probably. Try to minimize that way. I find the window eventually. That's interesting.
Is it hiding underneath those two? No.
Let me try the stop share.
There we go.
I had to do that. So yeah, I think that's all I had. But like I said, my even with these examples, like I said, I find Reticulate pretty. To me, it's kind of like a really powerful tool from within R. And one of the use cases is that for me it's more like Shiny, where let's say even if everything is in Python or something, still for the web app piece, I don't need to learn another new web app tool. I could just use Shiny, and just since it's so easy to wrap a Python function in Reticulate, so it kind of gives you the best of both worlds. So.
Yeah, the part that you mentioned about the operators, when I saw that, I was like, oh, that's very interesting, because you can now go in and redefine those to be whatever you want them to be. You could create your own. It's almost like you can create your own little syntax,
Yeah, in fact, that was in one of those Reticulate issues. And like I said, I'm not sure, maybe I just took like a piece of code from that suggestion in that issue and put, so I'm not sure if this is the best practice or not, but I remember in that thread, JJLR did mention that even in TensorFlow, they kind of do that, but I'm sure they do it in a more, in a way that is more robust kind of thing. So, because that really makes it a lot more powerful, because now you don't need to worry that if somewhere they're adding two Python objects within the thing, that still works. So.
Another piece that I noticed was that earlier Brian mentioned that you can, or he brought up, he wondered about choosing a Conda environment, and as you guys were going through that, I was thinking to myself, oh, this is because you can choose your environment. I was thinking about how I could use it. I know now when I set up my Python environments, I'm using a tool called PyEnv, And with that, it's basically says, hey, put a little virtual environment in this directory.
Oh, okay.
And so between that way, I can say this project is using this version of Python and it has these packages in it.
Ah, okay.
And you can do similar stuff with RENV. You can like decide what packages you want. And there's another package that the name is escaping me, but it basically does what PyEnv does, which allows you to choose a version of Python. It does that for R. So you can have multiple versions of R sitting on your computer and say, hey, I want to use, when I'm in this project, I'm using this version of R, you know?
Okay.
And so that, it just reminded me of that. How nice would it be if you could, inside of your reticulate code, you can say, I'm in this project, and when we're in this project, we're using this Python virtual environment, and your R environment will, or your R version and stuff, that'll come automatically because you're already in the R script. But just for reproducibility's sake, to be able to say,
Right.
you know, here's the Python environment that we're using.
Yeah.
Hey Derek, the R environment package manager that you mentioned, is that something new?
Yeah.
Is it stable? Is it stable yet?
I haven't tried it myself. I'm gonna see if we can get the developer of it to come and talk to us. I think he's down in South America, and so I just kind of came across it. I just came across it like 2 weeks ago or something when I was working on my little Skunkworks project. I was thinking to myself, man, I'd really like to be able to do this thing in like be able to switch or really inside my make files. I want to be able to say, when you download this project from GitHub, run this command and it will set up the version of R that you need and all your packages and stuff, you know, for reproducibility's sake. And so came across a GitHub issue where or some kind of like Stack Overflow question or something, where he chimed in and said, hey, I have this package that might be helpful. And I took a look at it and I was like, that feels like what I want to use, you know? So,
yeah, we use that. You talking about RENV?
not RENV. So RENV will keep track of your packages.
Right. Yeah.
Is something that will allow you to keep track of your R versions.
Oh, okay. Now, what is it called again? I'm sorry, I joined a little late.
I don't remember what it's called. Let me look it up because I wrote it down.
Okay, yeah.
I wrote it down because I was like, I need to reach out to this guy. So, oh, here we go. Oh, I totally didn't. Right now. Hold on, let me look it up real quick. Because what I did was I wrote the URL in here. Did he call? This work leads me to the RENV installer project. I think he called it RENV installer. Let me just put a link over here. All right. So just put the link in the chat. Called RENV installer.
Cool, thanks.
So I haven't tried it out myself, but when I read through it, I was like, yeah, this feels like something I do want to try.
Nice. Yeah, we got At work, we've got RStudio Server Pro, and you can switch back and forth on versions of R on that, so that's pretty nice as well. Yeah.
Yeah, I've always found like just having on my personal system having multiple versions of R just to be like
Pain.
and Python really.
Oh yeah, yeah.
It's a real it ends up being a hassle because I'm like, oh, how do I put the right one into my environment shell and all that stuff.
Mm-hmm. Yeah.
They got it well figured out with Python. I know you say I use Conda for that kind of environment. I mean, it's pretty stable right now. So that's one thing I hate about not having an equivalent in R.
Yeah, it is pretty nice how that's set up with Python. Yeah, and like you say, Conda is good, Anaconda.
All right, guys. So I'm about to drop off. I enjoyed the meeting tonight. Learned a lot. Thanks, Shanker.
Yeah, I'll try to actually join on time next time. It's very cool that we have this. Anyway, yeah.
No problem. We'll try to get this video up onto YouTube in the next few weeks, and we will catch you guys next month. Got a couple of potential